Good morning. Welcome to AP Computer Science A. Today, we are going to cover section 10.2, recursive functions, but now with returns. So be sure to have your notes with you. Be sure to have your repo opened up to section 10.2, type in your name, period, and don't forget to click submit once you are done so you can get credit for this assignment. So today we are going to be covering recursive, same that we did last time, but now it's going to be recursive with returns. So for a common exercise that often you'll see in computer science with recursive are factorials. If you remember from your math class, a factorial is, if we have, for example, 5 factorial, that is 5 times 4 times 3 times 2 times 1 is the last number. If I do 8 factorial, they will be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So one of the key things to recognize and to be able to figure out is what is the last number that you are going to use. Well, in this case, what is the last number that you're going to multiply? You're going to start at 5, and the last number to multiply will be 1. You're going to start at 8 all the way down to 1. So therefore, the 1 is going to be your base case. So let's go start building our factorial method. We make additional spaces. And now I am going to start creating my method. It's going to be a public method. It's going to be static because we don't need to create an object. We don't need a constructor to be able to call this method. It's going to return an integer, and it's going to be called factorial. It's going to take in as a parameter an integer, and we're going to say num. And we are going to start by recognizing our base case, which is when num is going to be 1. So if num equals to 1, then what do we need to return? We are going to be returning the 1, which is the number that needs to be multiplied. So therefore, we are going to return 1. We're not going to create an else statement. We're just going to say, well, if it's not equal to 1, then we are going to return, and because we need to be able to multiply, we are going to multiply the number times factorial num minus 1. And it's going to be minus 1 because it's going to start with 8. Then we want to be able to subtract 1, so it'll be 7, 6, 5, 4, 3, 2, 1. Once it gets to 1, we are going to start ending or exiting out of our pyramid or boxes. So now I can go and call factorial. I'm not sending a number, so let's start with 5. Now, in this case, this is going to return an integer. So therefore, what do we want to do? We want to be able to save into an integer once it gets returned, or we can print it out. So we can say system.out.println, and we're going to print the number that will be returned. So let's see. 5 times 4 is 20. 20 times 3 will be 60. 60 times 2 will be 120. Times 1, that will be equals to 120. So therefore, if I run it, it should give me 120. And it does. Now, if I type in an 8, then it'll be, let's see, 120 times 6 will be 720 times 56. I'm going to cheat and I'm going to use my calculator for this. So therefore, your calculator, if you use any of the scientific calculators, you know that it does have a factorial in there. And in this case, it's somewhere so the 8 factorial. In this case, it's on top of the x minus to the power of -1. So it'll be 40,320. So according to our calculator, this will be 40,320. So let's go and run it. And that is correct. Now, there's several things that you need to be able to keep in mind. Is that whenever you are going to be calling the same method, where you're going to be able to, this is where the recursion is going to occur on line number 22, you always want to be able to modify the value of num, either subtracted by 1, added 1, multiply by 2, divide by 10. If you just keep it as num, then you're always going to be passing 8, and that's going to create an infinite loop that's going to give you an error. Or is there a specific? So notice that it went all the way through. And it's also a stack overflow. It runs out of memory. But in this case, they usually stop it before you run out of memory. So in this case, we have a -1. So let's go and trace it on paper. And I'm going to trace it with the number 5, just to be able to make the tracing a bit shorter. So if I run it, it should give me 120. Like 120. So now, let's go and get a piece of paper. And let's go and trace it the same way that we traced it on the last lesson, where we are using our boxes to be able to represent the recursion. And we have first, we are going to start with the number that's going to go through. It's going to be 5. I'll make my first box. It will be n equals 5. And is n equal to 1? No. So therefore, we're going to return a number. Whenever I return a number, I'm going to make a little box to be able to keep track of what the number is. In this case, is 5. And it's going to multiply by a number that's going to come back later on. Now, in this part, it's going to be calling the same method. Now it's going to be factorial by n minus 1. So I'm going to create another square inside. N minus 1 is 4, so therefore n equals to 4. So it's going to come through here. 4 now. Is num equal to 4? No. Equal to 1? No. So therefore, we're going to come back over to line 22. Once again, I'm going to return the number, which is 4, times something here. Now, it'll be num minus 1, so the next one will be 3. So n equals to 3. 3 comes through here. Is num equal to 1? No, it's 3. So therefore, we come back over here. It'll be 3 times the number that will be coming back. Now, num minus 1. So now n equals 2. Is num equal to 1? No, now it's going to be 2. So we don't go through the if statement. Now will be num, which will be 2. Now this part is going to be essential to be sure that you trace it correctly. Times the number that's going to come back. We're going to call the same method factorial. We're going to call itself. Now n will be 1. N equal to num equal to 1. Is num equal to 1? Yes, so we're going to return 1. So therefore, the number 1 will be returned. 2 times 1 is 2. So therefore, the 2 will be returned. 3 times 2 is 6. The 6 will be returned. 4 times 6 is 24. That gets returned. And 5 times 24 will be 120. So notice that by creating the boxes, whether you complete the boxes or not, you're going to be able to see how many levels you need to be able to get out once you are inside. Now, there's going to be other variations that you might see for this. In this case, sometimes I'll say if number is greater than 1, then they are going to place this here. Otherwise, we're going to terminate and return a 1. So this should return the same value, which will be 120. There you go, 120. Questions? So there's going to be different variations that most of the time you'll see it in this form, where your if statement will be your base case, but there might be other variations that it is important that you take the time to trace your code using this method in order to be able to get the answer correct. Remember that you don't have to actually code a recursive method in your APCSA. It's going to be part of your multiple choice. So another thing that they might ask you is to be able to, they might just give you a code, a method, and they'll ask you what is going to be the output. So let me go and place it here. If I trace the mystery, and they're going to say, well, what if I call the mystery method what, and I type in a, let's say 5, what will it return? So see if you can trace it using a 5. Go and trace your mystery method and see what the recursive method will return. Go and pause it. You got it? Okay, let's trace it together now. So using the same method, the same process of tracing the code. Let's say first we are going to start with n equals 5. So n equals 5. And I'll place my first box. So therefore it's going to come through here. Is n less than or equal to 0? No, in this case it's 5. So therefore we're first going to increase by 1. So therefore num n will be 6, or num equal to 6. And then it's going to return the number plus, we're going to call back our method, so the recursive starts. I want to place a little holding place for first the number, num, which is 6, plus Then later on, we're going to come back to this number. This number will be returned. Let's go through the next one. So now will be num minus 2. So now n will be 4. We come back over here. Is num less than or equal to 0? No, it's 4. So therefore we come back over here. We add 1. So now it's going to be 5. Return num plus the mystery. So therefore I'm going to place a placeholder here. So it'll be the num, which is 5, plus a number that's going to be returned. We're going to go further inside our recursion. Now it'll be num minus 2, so it'll be, it's 5, so now it'll be 3. Come back over here, int equal to 3. Is it less than or equal to 0? No. We come back over here, we increase it by 1, so now it's going to be 4. Or placeholder here, plus, we're going to come back to this. We go back inside, will be minus 2, so now 4, this will be 2. Is it less than or equal to 0? No. We're going to increase it by 1, so now it's going to be 3. So it'll be 3 plus a number. That's going to come back. Minus 2. So it'll be n will be now 1. We come back over here. Int is 1. Or so the num is 1. Is it less than or equal to 0? No, it's 1. We're going to increase it by 1. So now it'll be 2. We are going to return the num plus the number that's going to come back over here. Now will be num minus 2, so now num will be 0. Is num less than or equal to 0? Well, it is equal to 0, so therefore we're going to start coming back out of our recursion. So we're going to return a 1. Not a 0, but a 1. Now, 2 plus 1 is 3. 3 plus 3 is 6. 4 plus 6 is 10. 5 plus 10 is 15. And that will give me 21. So therefore, if I press run, that should give me 21. We're going to clear my screen. And that is correct. But on your AP exam, you'll have 1 or 2 questions, probably just 1, that deals with recursion. And it is essential that you build your boxes as you go into your recursion, so you are able to find out how many levels you need to come back out of the recursion to be able to find your correct answer. So this is the lesson for today. Have a great day, and I'll see you next time.